Unmute. There we go. Hey, I can't see it. Okay. Here we go. Now, what did I say? E to B, firstly, wasn't it? So you had square, square, and then triangle here. Now, each of these, we can just say for the moment 1 unit, 1 unit, 1 unit, 1, 1, 1, 1. If these are all the same, it means each of these angles must be 60 degrees. If this is 1 unit long, then here to here is half a unit, and then here to here is half a unit. I could make this a right angle triangle. So this is half a unit here. This is 60. So what would this angle here be? 30 here, and this is right angles here. So I would like to get this base here. So I could say tan 30 equals a half over x. So then I can get x equals 1 over 2 tan 30. Now what's tan 30? It's root 3 over 3, is it? What's tan 30, Miranda? So if you can type this in, please, for me and tell me what you get. The whole thing here? Yeah, but give me the whole thing here. The whole thing here is root 3? Okay. Look, guys, I just want this whole thing here, please. For the whole thing? Root 3 over 2. For sure? Alright. Right, so that means this length here will be root 3 over 2 times the lengths of these. So it's a little bit longer. Now, what's root 3 over 2 as a decimal actually? A little bit shorter than 1, isn't it? Yeah, so anyways, it's a little bit shorter than 1 unit. Okay, so we want the vector that goes from here, what is it, B to E or E to B? What's Q? Which is it? Here. Okay, this one to this one. So if you look at it, you can think about it like this. E to B, I could say, is this length here. Whoops, let me get a different color. This length here, and then this vector here, and then this vector here, and then down. So you could say E to B would equal root 3 over 2. Now, you notice that this vector going to the left here is exactly the same as, I think we want to use this one down here. Isn't it BC? Is this a C here? Yeah, and I tell you to give me the answers as a BA and a BC, right? Okay, so it's root 3 over 2 minus BC, and then minus another BC, and then minus another BC, and then what vector would be down half a unit? Minus a half BA, yeah. Because BA is up, so minus BA is down, and it's half of it. So simplifying, you'd get minus brackets BC, so that's root 3 over 2 plus 1 plus 1, so that's root 3 over 2 plus 2, So that's root 3 plus 4 all over 2. And then minus a half BA. That is a tricky one, yep.
That feels like E then goes down.
Yep, you'll get the same answer.
And wouldn't
You'll get the same answer.
No, wouldn't 3 lengths equal 1 of the triangle? The angles.
When you say go down, give me the letters. Which, from where to where?
E,
E, D, is it?
yeah.
Yeah?
And then DC, then CB.
E, D, C, C, B, yeah?
But like, the triangle, shouldn't
The length ED would be 1. True.
and EF also would be 1?
Where's F here? Is it here?
Yeah.
Yeah, correct, yeah. So what are you getting at? Faisal, ED needs to be broken down into terms of ABC as well.
I'm sorry, for the first, like, the second line, first minus BC.
This one?
Yeah.
Oh, that's just me looking at the instructions to go from E to B. So I have to go left, left, left. The first left is actually a little bit shorter than these lefts. It's actually root 3 over 2. So it's root 3 over 2 left, and then 1 unit left, and then 1 unit left, and then half a unit down.
I'm sorry, the second line.
This one here,
3
plus 4.
word.
Oh, I'm just adding root 3 over 2, a 1 and a 1. If you can check on your calculator, I think it will be that. Did you write that down, Curdy? For sure? Where's Joseph? Is he really sick? Alright. Who else? Joseph, 1, 2, 3, 5, 6, 7, 8, 9, 10, 11, 12. Joseph Sadiq wasn't in yesterday as well, was he? Oh, I didn't have maths yesterday with you. Is Sadiq sick? Unknown. And Brendan's here, surprisingly. Yes. Am I missing someone else? Somebody else from this side of the room. Sadiq. Joseph. Oh, you're sitting over that side of the room. That's what the problem is. I'm so used to seeing you over here. Okay. So now, once you have that length, root 3 over 2, all the questions with E in it now are not so difficult to do. Okay? So we'll start the next lesson now. Keep that. All right. Next lesson now. So let's get the worksheet here. Okay. We'll have a. Would you like the two of you? Would you like to leave? Would you?
Is it on silent?
No. Now, we'll need this diagram in a moment. So what we're going to look at now is something called a position vector. So we've done vectors, Euclidean vectors, and the last category of vector is called the position vector. So please make note that's the name of the lesson, position vectors. Okay, so what exactly is a position vector? Normally when we have our diagrams, for example, A, B, C, we always have in our mind a point which we call the origin O. Just like with our XY graphs. And just like with our XY graphs, where the origin is not so important. So in fact, I just drew it here. They'll usually give you the origin in the question, but if they don't show you where the origin is, you're free to put it in any point. And in fact, where you put it will not change the equations, the formula I'm about to show you, okay? So firstly, these vectors here, O to A, O to B, and O to C. So there is OA, that is OB, and that is OC. These are called position vectors. So in other words, a position vector is any vector that starts at the origin. So that's the definition. So position vector starts at origin. So please write that down. Position vector starts at the origin. Now, the second thing is that with position vectors, it is always the case that you never write the letter O in it. So you do not write, or well, you can, but you don't usually write OA, OB, OC. Instead, you just write A, B, and C like that. Okay? So position vectors, they look like they're missing half, but they're not. When it is absent, it means it is an O origin. So because of that, we can get this nice formula now called the triangle formula or triangle rule. So, for example, Sadiq, why are you so late? Silence and yes? Is it a good reason? Yes. Now hang on. Is the reason good enough that I think it's fair that I tell you you can come in? You know what I'm saying? Because if you're this late, I'm thinking I shouldn't let you in. But do you feel the reason is good enough that I go, yeah, that's okay? Yeah. For real? Okay, sit down. And I guess I'll find out at the end. Okay, so triangle rule now. So suppose we want to find this vector here, A to B. So A to B. Well, if you look at A to B, you can see that A to B is A to O plus O to B. Can you see that? A to B is A to O plus O to B. Good, okay. Now A to O, if I swap the A and the O, I have to put a minus in front. Do you remember that rule? And then O to B, I can rewrite that as just B, because it is a position vector. Now what about O to A? I can rewrite that as minus A. So minus A plus B, or in other words, B minus A. So this is how you can take any Euclidean vector and write it as position vectors. In the exam, you will be mostly dealing with position vectors, and you will need to change your Euclidean vectors into position vectors. So this is an important, although simple, but important formula. So please make note of that. Yes? Okay.
I'm sorry.
Yes?
We always change to minus, or if it's minus, we change to plus.
Yeah, the sign changes. So when you flip, the sign gets changed. Okay. What I'd like you to do is draw this, and we'll look at some examples. Plug it in. And wait, just before you draw it, I need you to note Oh, that's a typo. What I need you to note is that the distance from, what was I? Ignore that and that right there. Let me get rid of it there. I want you to note that the distance between W and Z is 5 times bigger than the distance from X to W. So this is 5 times the size of this. Okay, so please draw this. I'll do some questions with it now in a minute. So if you can't tell, the little arrows there are showing you that the lines are parallel. What's the name of this shape? Parallelogram, yeah. Also, you can't quite see there, you see those 2 little ticks beside the M? What's that telling you? The equal length. So the M is in the middle from W to Y. Okay, so let's have a look at some examples now. So I'll just flick between this and my questions. The question is, I want you to, well, if you remember the last time, I said, any vector can be written as the sum of 2 non-parallel vectors. So for this one here, I want you to write all these vectors in terms of x and y. So let's start off with z as an example. Okay. So z, z equals, so if I look here, I can say z, well, what is z? It's a position vector, so z is OZ. But OZ is exactly the same as XY. So I can say z equals XY. But this isn't good. I mean, it's nearly finished. I don't want the answer as XY. I want the answer as X and or Y. So, no, Y minus X. Yeah. So that's Y minus X, or it's quite usual to write it like this: minus 1x plus 1y. So you're emphasizing how much you have of each. So you have a negative x vector and then 1 positive y vector. Okay, so that's just to get us started. So can you write this one down? Yeah. All right. I'll flick back now in a minute. So the next one would be W. Okay. So the vector W is O to W. So if I look at this now, what can I say O to W is? I could say it's O to Z plus Z to W, yeah, or I could have said O to X plus X to Z. Does it matter which one? I think I'll choose the OX to XW because it immediately gives me an X which I would like, okay? Although it doesn't matter. It doesn't matter. So W would equal, O to W would equal OX plus XW. So that equals OX plus xw. But OX, of course, is just x. But xw, you could write that as what?
1 over 5 x z.
Yeah. You should not use the law on xw. Why not? Why would you not? Well, if you did, what's xw? It's w minus x. The minus x would cancel this and you'd be left with w equals w. So it's not helpful there. What you should now use is the fact that xw is how much of xz? No, not 1/5.
1/4.
Not 1/4. Go the other direction. 1/6. Because this is 5 units of this. So xw is 1/6 xz. So that is 1/6 xz. Now we'll use our formula. So xz, what's xz? Z minus x. So it's 1/6 z minus 1/6 x. Now, that's nearly finished. If you recall, we have a formula for z. What is z equal to? Minus 1x plus 1y. So you can write this as x plus 1/6 minus x plus y minus 1/6 x. So if you group these together, you got an x minus 1/6 of an x minus 1/6 of an x, so that's 2/3 of an x. And then here you have 1/6 of a y. Oh, that's it. Now I'll give you a moment to write that, and then what I'm going to do is I'm going to draw this to show you that it actually is the same as w. Okay, I'll go back to this, don't worry. 2/3 x plus 1/6 of a y. So if I want to go from O to W, I'm saying O to W is the same as 2/3 x, which would put me about here, then plus 1/6, well, actually maybe about here, then plus 1/6 of a y. Now what is a y? A y is this direction, O to y. So that's kind of a diagonal direction. So it'd be 2/3 x, and then we go diagonally 1/6 y. So it roughly looks like this. You're going, yeah, 2/3 of an x this way, and then 1/6 of a y that way. And it gets you in the same spot. You can see it's not quite to scale. So 2/3 of x would actually be about here. Oh, I guess it's okay. And then plus 1/6 of a y. Yeah. I'll do another one now. So m next.
How w is related to xw.
Right, let me flick back here. Is a particular part here?
The first example was z.
Yeah.
And look at that oz and xy on top.
Yeah. Yeah.
This,
So OZ is identical to XY. Yeah.
so why we don't do the same? Like,
Oh, why don't we do something similar for W? Well, let's have a look.
like ox and zy on the other side, on the right hand side.
Wait, slow down there. Take me back to here. So what are you asking me could we do with the W here? Okay. Miranda, it looks like you had a similar question.
Yes, now I know.
No, okay, go ahead, yeah.
I need to see the picture.
Right, yep.
Why we don't say that OW
Yep.
is the same as WY?
Ah, but it's not.
Why? It looks like it's...
Oh, it does not look like it. OW is to the northeast.
Then how it's the same to WX?
WX? It's not.
Then why it's related to XW?
Hold on. There's W. Now, I said W is OX plus XW. So if we go back to the graph, I'm saying OW is the same as going from O to X and then X to W. It's a lot like saying, if you watch, flick to the left, 5 meters north is the same as 3 meters east, 4 meters north, 2 meters north, 1 meter south, and then 3 meters left. It'll get you from the same starting point to the same ending point. So none of these here is like this one. They're all different compared to this one. But when they all add together, they make the same thing. So I'm not saying OW is the same as OX. It's not. I'm not saying OW is the same as XW. It is not. What I am saying is OW is the same as OX plus XW. Because if you use your parallelogram law, further left, there is OX, there is XW. Do you remember the parallelogram law? What do? You start, there's the first vector, there's the second vector. So we have to move this one down to here. So down it goes, and there it is there now. And then we have to draw our 2 parallel lines. So this one parallel, and then this one parallel, and then where they meet, that's the answer. And you can see that that one there will be the same as OW. I do not know if that helped at all. No, okay. Oh well. I don't know what else to say. Okay, let me tell you what you can do for a moment. I'd like you all to try and give me the vector M here in terms of X and Y. So give me M there. Sarah, do you need me to leave this up on the screen, or it's more just doodling? Okay, so I want you all to try M now, please.
Understood. M is exactly at the center of
Yeah, it is, yeah. It's exactly between W and Y.
So it would be...
It'd be a half of WY, yeah. And it is tricky. It'll have more steps than what I did. Did you get it? Are you trying? You've accepted your fate that you're not going to get it even if you try, yeah? Okay. Are you in the same boat? Yes, okay. You want me to check?
It's only like this.
Maybe I've made it more complicated. M is OZ. plus a half zy. Not quite this. If you look here, it'd be this one here, and then you'll have half a zy, so you'd finish here. You need to finish here. You get what I'm saying?
No.
Yep, alright. You have to start at O, and you have to give instructions to go from O to M. So I would say OZ, ZY, and then YM. You have to finish at M. So there's more here to it. Yeah, sure. I'm going to do it now in a minute, but I think you have it. It looks like the right number of steps. You get it? No. No, this is that face, isn't it? The one where it's going, okay. You know that one?
Can you
No.
see that?
No, I don't think any of you have the internet at home. Yes?
Can you see that? OZ, ZY, YM.
Yeah.
Do we like write plus in between?
Oh, yes. Yeah. Let's have a look at this one here. OM. Okay. OM, well, maybe to be more explicit. M, by the way, guys, I'm getting tired of putting the little arrows on the top, so I'm going to stop doing that. Because this looks like bold. M is OM, and OM, well, what can we say OM is? We've got a few choices. I could say, I think I'll go OM, we could go with OW, and the reason for that, we have W, I am plus a half WY, so it'll be OW plus a half WY, which is W plus a half WY. Yeah? Oh, I think yours was longer. I think there's a shorter way to do it. You went a different direction, yeah. Because I can use my rule here. I'm okay to use my rule here because it won't do anything weird like cancel the W here because there's a half in front. So it's W plus a half Y minus a half W. So what will it equal? A half W plus a half Y. Now, do we want Y in our answer? We do. So that's fine. And we have something for W. So can you read out what was our answer for W? 2 over 3x plus 1 over 6y plus a half y. So that would become 1 over 3x, and that is 1/12 of y plus 6/12 of y, so 7/12 of y. Yeah? So that's, I'm saying roughly, no, not roughly, sorry, exactly 1/3 of x plus 7/12 of y will get you from O to W. Let's see that. So 1/3 of x will have me finish in here. And then, what did I say? About half of y. So then, this is y. So half of y would be about from here to here. So I'd go 1/3 x plus about half of y. You know, it'll get you, huh? What's wrong? I can't, I wish I could draw here. Let me draw it here. Look. Hey, x is this vector, so that would be roughly this length here, okay? And then y is this long vector here, so that would be roughly like that vector there. There's x and there's y. 1/3 of x would be from here to here, plus 7/12 of y, so that's plus about half of a y. So that would go to about here. So if I add these two vectors together, it would make this one here, which I'm saying is exactly the same as the m. So let's have a look. See, there's the m there. It's, of course, it'd be nice if I could write on this, but I just want you to see that a third of x plus about half of a y would get you from O to m as well. I better do another one. Oh, okay.
Could you just a second for me? Yeah, okay.
Oops, sorry. Do you need the top? Yep. Well, you don't need to understand anything. You just need to be able to do it. So that's the first point. And second point, this is a section B question, which means you could choose not to do it, but you can't avoid it if it comes up in section A. No, factors will usually be its own dedicated question. But you got, I don't know, I don't think factors is a crazy difficult question. I mean, you do remember integration of improper partial fractions, don't you? Yeah. So if I had the choice between integration of improper partial fractions and vectors, I know which one I'm picking. Integration every time. It's fine if factors wants to be the question you definitely don't want to do, because I'd recommend you have to choose 4, so you should be prepared for 5. So the way you think about it is there's one question you probably will not do, definitely not do, and you prepare the other 5. I personally do not feel vectors is the question you say to yourself, I definitely won't do. I would think of all the questions, it would be integration of improper partial fractions is the one you say, I definitely won't do. That's what I think anyways. Guys, if you're having trouble with factors, don't forget, I put on Moodle at the bottom of the page links to books. So the recommended book for this course is, there's a few, but there's one called Pure Maths C3, C4. I think you have that one, Hassan, don't you? Or you have C1, C2. You can buy C3, C4, but I have the PDF ebook version on Moodle I acquired via websites. Some website to do with pirates. I can't remember the name of it. But there's the ebook version on Moodle. Something like this, I believe. Maybe. So you don't need to buy it unless you want a hard copy of it. But I do recommend having a read of the vectors chapter in it, because it is well explained with lots of examples, okay? And I think the problem here is people need more examples maybe, okay? So have a look at the book tonight if you want more notes on this, okay? It's, I can't remember, there's 2 files, one for C3 and one for C4. I don't know which of the 2 books it's in, okay? It's in one of them, Pure Maths C3 or Pure Maths C4. So have a look, because I really think it is much better to do this one in the exam than the integration one. Yes? No? You just, vectors not doing it for you. No. Okay. It's okay. It's okay. Factors isn't for everybody. Alright. Well, it's only one class now, so we'll have to leave it there. Before I might forget, after the next class, Joan will want to see you in the office just to talk about it. Do I have any other messages? No. Okay. So I'll print this out. No, I can't print this out. At some point, I'll put the worksheet on Moodle for you to practice, okay? So you precious.